Now you can see I mean, I have shared this screen. So probability distributions. Let us in this class let us discuss about the probability distributions. So I mean, the R is a set of statistical tables. So okay, that's not. I think you for because you are all statistical students, students. I need not tell you regarding the distributions. Okay. So now actually for there are several distributions. You can see we have a list of beta, binomial, Cauchy, chi-square, exponential, F distribution, and gamma distribution, and geometry, so not. Oh, number of distributions we are having. Okay, so let us start with, I mean, actually here you see for each distribution, for any distribution, what all the facilities we are having here is we can find the densities or probability mass function for each distribution for at a given value, and similarly at a given value we can find the cumulative distribution function. And similarly, for a given probability, we can find the what is the quantile value. And similarly, using R, we can we can generate a random numbers from that particular distribution. You see, we have to here you see the R name. So, for example, binomial, we have to use BINOM. This we have to always use that one. For finding probabilities, actually, for finding the density functions, we have to, that means probabilities, we have to use the D prefix. Suppose we want to cumulative distribution function, we have to use the prefix P. Here you see, prefix the name given here by for a quantile function random. This is the, I have highlighted that one, you can see here. Okay, so D is for the finding the probability is density functions, that means probability values, and small p is the, that means in our sense small d is used for finding small f of x, small f of x or small p of x. Whereas small p, if you use a small p prefix, that will give you capital F of x or capital Q of x. Sorry, capital P of x. Whereas Q is nothing but actually the quantile function. That means you have given, suppose the probability of x, capital X less than small x. So that small x it will find. Okay. Similarly, R is the random numbers. It will generate the R number. That means you have given capital F of x value for a particular distribution. If you are given a capital F of x value, x is nothing but capital F, and it is inverted value. Okay. So, for example, now let us start with, for example, binomial distribution. That because that is the most basic discrete distribution. How to find, how to using the I mean, that means how to find the probabilities and how to find the cumulative distribution function, and how to find the random, how to generate the random numbers, and how to find the quantiles. So all those things let us discuss using the binomial distribution. Okay. First, let us see. Let us take that means what that called probabilities DBINOM. Okay. So for finding the, that means P of x, small p of x. What is the formula for P of x for binomial distribution? NCX, e to the power of x, q to the power of n minus x. So for that, so what we have to, x is equal to, we have to give, it will find, that means x not x, actually we can say that px probabilities. Okay, p of x. So by yeah, DBINOM. Okay, we have to give the first n value. N value is, for example, 10, for example. Next, we have to give the probability value 0.5, for example. Okay, now you can see, yeah, n, yeah, let me see. For binomial distribution, size, probability. Okay, so when we are giving the P density, Okay. Yeah, we have to give the x values. That is the thing actually. So that is the missing here. Okay. So now let us take x is equal to, okay, actually that is 0 to 10, 0 to 10, because x is equal to 0 to n. Okay. Now let us see. We have to give x here. Okay. N. Now you can see. These are the binomial probabilities. You can see these are symmetric also, because we have given the p is equal to 0.5. You can see here. Okay. And you can check it. Sum of px. Yeah, you can see that is the one. So this is how to obtain the all binomial, actually binomial probabilities for a given n is equal to 10, and p is equal to probability is equal to 0.5. Let us generate for some other, for example, x is equal to say some 20, x is equal to, that means n is equal to 20, or you can say, you can take like this way, n is equal to 20. Okay. Now you take x is equal to 0 to n, 0 to n. Okay. So p of now p of x is equal to x comma n comma, here you see x is the vector, so here p is equal to, we can take probability whatever it may be the value, some 0.75 for example. Let us take that one. Now you can check what is px. Okay. So now if you want to take the sum of that one, sum px, so you can see that is 1. Okay. And of course we can also in our own way we can find the probabilities, binomial probabilities. That's a different issue. Okay, that I will demonstrate here. Just I think yesterday I have demonstrated that one. Here you see I am using binomial probability BP is equal to okay, NCX means n is actually, so CO factor, I mean choose CHOOSE, choose n comma x. Okay, that means NCX star p to the power of x. What is p value we have taken? So 0.075. Okay, so p to the power of x, oh, sorry, 0.75 to the power of x star 1 minus 0.75. That means 1 minus 0.75 to the power of n minus x. This is the formula, you know that one. Okay. So now you can see exactly this one and this one, what they are exactly same. You can see here. So this is actually, this is the using the d by binomial function, whereas here this is we have generated using a different one. Okay. Now you can see some sixth value. Okay. So they are same exactly. Okay. And you can also check the some condition by applying some condition. SUM PX, sorry, some BP. Okay. Okay. So that is how you can find out that one. Okay. Now you see, so this is how to generate, how to find the binomial probability. Suppose we would like to find that is what is called cumulative distribution function. Okay, that means capital F of or capital P. Capital P is equal to, for example, okay. Now let us take this one. Is yeah, this is capital P. Okay, this here you have to give P binomial. So when we would like to find this cumulative distribution functions, cumulative distribution values, you have to give the same value p x comma n comma 0.75. Now you can see. Let us see what happened. Okay, so capital P. So now you can see here. So what happened here? You can see the last one. You can see here we got 1. So that means they are the cumulative probability. This is the first one is x is equal to 0. So we have to